Hi everyone, we are Tommaso,
Francesca,
Maria Grazia, Rosa,
and we are now going to present you the technical video for the assignment number 9 for the programming for IoT course. So this is the, I would say, physical connection for our project. As you can see, we decided to use the DHT11 temperature and humidity sensor that we'll send to the various platform that we are considering the data about temperature and humidity. The Raspberry Pi is attached to the modem through an Ethernet cable, and we decided to use an IP to give to the Raspberry Pi an IP static address, and the DNS servers used are the one provided by the network, but we could have also used the Google one.
So we access the Raspberry Pi through the PuTTY interface, and then we log in, and we are able to see the client code from here. As we can see, so the basis client code is the same for all the three platforms we are using. We have the client definition, which is here, and we connect the client to the IP address we provided for the Raspberry Pi during the configuration period. After that, we set the callback functions. This is the function that will be called during the after the connection. So we have the myOnConnect here, defined here. And this is the function that will be called after each message reception. Here we have myOnMessage received. It prints, it is an essential function for our code, and it prints the message, its topic, the quality of service, which is 0 by default, and the message payload, which is the JSON we will send. Then here we also append our message payload, our JSON, to a dictionary, which will be useful later, as we will see after that. And here we start the loop, which is the core of the MQTT client. In the loop, we need to subscribe for the topics. So we subscribed essentially for all the topics through this wildcard. So the client will receive everything which is published after in the loop. So here we have the publishing loop. As we can see, we call the getTemperature function, and we publish 2 temperature data for each single humidity data. The data are published all together 1 second after the other one, and they are collected in the dictionary. After that, because of some problems of the ThingSpeak platform to collect all data together, we send them to the ThingSpeak class. We send the dictionary to the ThingSpeak class, which we will see. So here we have the sendThingSpeak class, which performs essentially an HTTP request through a post, and so communicates to the ThingSpeak platform via REST. And as we can see, we are sending a single data each 15 seconds, which is the minimum required to visualize properly our data. Now what we have to do is just to launch the code by doing here, and we can see on the screen that we are starting publishing data. It's 1 per second. And all those data, as we said, will be collected into a dictionary. So until now, we are not communicating yet with the platform. We wait for the platform to be reached. And now we can see that the server answered with a 200 OK, because it reached the first temperature data. After 15 seconds, we will be able to see the other one here, and then the first humidity data.
Now we can go to ThinkSpeak. Here we have the channels where all data arrive. For example, this is our channel measurements, and if we go here, we can see that we have many tabs. For example, private view, public view, and also other settings for the channel, such as the read and write API key to manage the data. If we go to the private view, we can see that here we have two charts, one for temperature data and another for humidity data. And for example, here we can see the last temperature data published by Raspberry Pi and also the humidity data. Then we can have a look at the applications of ThinkSpeak. As we can see, we have many applications here. For example, if we click React, we can see we have created many React tree. And for example, the first is linked to Twitter. In this React, we check if the temperature value is greater than 25, and if it is happened, we publish a tweet with this message. And using the Twitter account that we have linked before with another ThinkSpeak application that is ThinkTweet. Another React that we have is React for Push Bullet. That is another application that let us to receive notifications both on PC and on the mobile phone. Here we check the same thing if the temperature is greater than 25, and this time we trigger a ThinkHTTP, that is another application of ThinkSpeak that we will see later. Now we can see a demonstration of how React works, and for example here we can see that the temperature has reached the high value, and now we are receiving ThinkSpeak is receiving this data. And for example, we can see the first application that is Push Bullet that has published its not. And also, if we go on Twitter, we can see that we have published a Twitter with the message we have set. And we can see that also on Facebook we have the same message. Another application that we implemented is the ThinkHTTP. That is useful to connect to a web server and exploit the HTTP methods. For example, here we have the Push Bullet application. And here we set the URL of the service, and if the URL requires an authentication, we have to set the username and the password. Here we choose the method, and we add other headers that we need. And here we have the body of the post request. That is the message that we have seen in the notification.
So we can see now the code, the client code for the Siteware platform. It is very similar to the one we saw for the ThinkSpeak platform. We just changed here the subscription phase, which is performed inside the myOnConnect function, the callback function, but essentially we have the same shape of the code we had before. The loop starts as we saw previously, but in this case we don't have a limitation on the size, and we are able to send more data together. So we have a unique function, get temperature and humidity, and we are able to send all the sensor data together. Also in this case we call a class which acts through HTTP, which performs HTTP requests to the platform itself. The platform runs locally on our PC, so the address is the one of the PC on which the code is running, and we can see that we have a condition on the temperature value. If the temperature is less than 25 degrees, we send a normal JSON here through a post request, while if the temperature is higher, in the else section, we are sending an alert on which will be visualized on the platform.
So we are now considering the Siteware platform. The first thing that we notice is that with respect to both ThinkSpeak and Bluemix, we need to go through an installation of the platform which is done locally, and we also need to use a database server, which is, in our case, is MongoDB, and now we can also start with the on the startup.pet file the Siteware application. So just speed it up a bit, and now we are logging to Siteware. We have our device, which is associated to which is called an asset, and going into our device we have the various section with location, measurement, alerts. So under the section measurements we have the temperature and humidity measurements, which as we said before are sent together. And now starting the Siteware client, we can see that we are receiving the updated information about temperature and humidity. As we can see in this case now we have higher temperature reach, and so we can see that into the device alerts category, and you can see at this time there is a message which is the temperature reached high values. Also another interesting feature for Siteware is the forwarding of data to the initial state which is a sort of freeboard. And as you can see, we have the variation over time of the temperature, and as you can see here we have the message that temperature reached high levels, but it's I mean it's the last one that we have received, because initial state can only receive one data at the time. So if we are looking into the temperature, the alert won't be sent. So when the temperature was high, we had just the alert, but not the visual output on the temperature. And we can see that on this time scale we can modify it and see that how the temperature changes over time.
So the Bluemix code is a little bit different with respect to the previous one, as we can see here. First of all, we had to import the IBM IoTF library, which allow us to connect directly to the IBM Bluemix platform. The structure of the functions that get temperature and humidity is the same as before, but in order to create a client, we have to specify the device options, which are the name of the organization, which will be seen on Bluemix, the type of device, which is the Raspberry Pi, its ID, which is the MAC address, and an authentication method. So we create the client with those options, and then we are able to perform the classic loop. And even in this case, we have no problems to publish data together. We publish data every 10 seconds. Of course, we are sending a JSON with both the data collected together, and we will visualize them on the Bluemix platform.
We log in Bluemix that provides us many services, and in the section, the catalog section, we can see the container, runtime, and other service. In particular, we choose the Internet of Things platform in the Internet of Things section. Internet of Things platforms allow us to connect our device. Clicking on the service, we access on the platform where we can add our device. In particular, we first create our type, our Raspberry type, and use the ID that is the MAC of our Raspberry. In the overview, we can see the data consumed and storage consumed of our Raspberry. And if we click on the device, we can see that the Raspberry are sending the data. In particular, the temperature and the humidity data are updated every 10 seconds. After the registration in Internet of Things platform, we go again in the catalog section and add the Node-RED application. Then we bind the Internet of Things with the Node-RED application, and then we can access to Node-RED. In Node-RED, we create our application, wired up the blocks that we choose on the left panel. We in particular use the IBM IoT block and a switch that represents our condition to alert the user with a tweet or with sending an email. When we're running our client code, if the temperature reach our threshold that we set in the switch node, a tweet will be posted. As we can see, a tweet has been posted on my account. And as the same in Facebook.
So in order to visualize our data, we exploit the Freeboard platform, and we are able to make the client code run on the 3 platforms and see the results on Freeboard. So we first launch the Bluemix code, then the Siteware one, and the ThinkSpeak one, and we are able to visualize the results here. So we can see that we choose a gauge for the humidity and a sparkline graph for the temperature, and now the measurements are going on. So we can see that here we have a 20 degrees temperature. It rised. This one was taken some minutes before. ThinkSpeak has taken some measurements later on because, as we said before, it first publishes the data, and then after the collection in the dictionary, it publishes it. So now we are able to see the gauge, the humidity gauge and the sparkline as before.
To demonstrate that we can send also the command from the platform to the device, we have implemented a simple web service that has a method get that has as parameter the URI, and it prints only this warning. And then we have changed the configuration for the host, and we have set the IP address of the Raspberry Pi and also the port. For ThinkSpeak, we have created another React, that is this, And this time the condition is the same. So if the temperature reaches an high value, we will trigger a Thinkac HTTP that we can see is different from before. This time the URL is different because here we have the domain that we have associated to the Raspberry Pi and through which we contact the web service. And other thing, this is a get method. The same Thinkac HTTP has been used for another ThinkSpeak application that is tweet control. It works always with the same Twitter account, and here we can see that we have a trigger word, and if we publish a tweet with this word, ThinkSpeak will trigger the Thinkac HTTP. So to demonstrate how tweet control works, we can launch the web service. It is listening, and if we publish this tweet, we will see here the warning.
So now we can see how we can exploit the web server on the Raspberry side from Bluemix. So we know that the web service is already running, and if we launch our client code through the Node-RED application, we are able to see that it receives an alert message here. So now we launch the code. And as we can see here, we are performing an HTTP request because we overcome the threshold, the settled threshold. And if we go here, on the web service side, we can see that we got a warning. Here, instead of the warning, we could have triggered every action we wanted, but in order to make it visible, we choose to print just on the screen something.